Yeah, we're live. 7:01. Actually, I was looking at some other stuff, some information actually for this video, which is very cool. So tonight we want to talk about cross-sectional area and where to go to get information to do the calculations, because I'm not going to put those up on a live video, but there's lots of different places to get that, how important it is. And the question for tonight is, does it actually change? Does it change in, and we'll even say average cross-sectional area, because that's really kind of what you're going to be calculating. It would be hard to get specific cross-sectional areas unless you did a lot of measuring. Um, is a change in average cross-sectional area, is it going to change where the thing makes peak power? And so we're going to talk a little bit about not only whether or not that might do that, but actually how hard that would be. There are all kinds of formulas and stuff, but how hard it would be to test that individual component because it's linked to other things, as we've seen in lots of these things. It's like guys wanting to talk about, well, let's just talk about lobe separation angle on a camshaft. What happens if we change the lobe separation angle? Now, I have done that test where I had them grind cams that were the same and then hopefully just changing the lobe separation angle, because guys wanted to see that. So I had them grind those tests and we ran them. But the thing is, it's only going to do that on that specific application. And then also what were the other valve events? What was happening on the other valve events? So I didn't get specific enough about having all the cam card information stuff in there. So I digress on that. But it's about the same thing, though. If your people want to look at one specific thing, what happens if I just change the lift on a camshaft? Or what happens if I just change the lobe separation angle? What happens if I change just the cross-sectional area? And then, I mean, almost by definition, if you do that, if you do increase the cross-sectional area, normally there's another change that goes along with that. And normally that's more flow. So it's fairly easy to surmise that one cylinder head that flows more than another head can support more power. In fact, I've talked about that many, many times. So if you have one of the other easy formulas that in no way tells you absolute data, is that if you have a cylinder head that flows 400 CFM, you can support fairly comfortably, you can support 800 horsepower. 2 horsepower per CFM of peak flow is a good estimate. It's not an absolute. It can't be, because I've made way more than 2 horsepower per CFM, and more often than not, I've made way less than 2 horsepower per CFM. And we've seen that on a lot of combinations. For instance, one of the good examples is running the LS3 head and then on the stock motor, and then running a ported LS3 head on the stock motor. And one of them flowed 315. I think one of them flowed 350, and we gained 10 horsepower. And it made just over 500 horsepower. So it wasn't anywhere near taking advantage of what that head had to offer. So, and I think what we'll see is cross-sectional area would be the same thing. So there are some really good places for you to go visit, and I recommend this channel or site or whatever all the time, because it's really good. If you want to go find good formulas for things, whether it's displacement or compression or dynamic compression, or in this case, average cross-sectional area, Wallace Racing, if you just remember, write that down somewhere, put a little sticky up on your monitor, and just go to Wallace Racing, because Wallace Racing has a ton of different things, figuring out your compression and your displacement and wheel and tire size, all kinds of things. It's like having the auto math book that I have that I don't have anymore, because now I've taken those all down. So that's a really good source for that. Also, I was just looking at SRH Induction, and he goes through some good information on what it takes because you have to measure. And when you're measuring the port, one side, the top side is going to be long, and the bottom side, the short turn. That's why they call it the short turn. So you're going to take both those dimensions and average them out. And so there's some math involved in getting the information, and then comparing that to the CCs of the port. And again, you have in some instances you have different length ports, and then what does it flow with the intake? So there's a lot of things going on there. But the reason that I'm talking about this, and I'm going to go ahead and put a poll up right now. Does cross-sectional area determine peak engine peak horsepower engine speed. So what I mean by this question is, does the cross-sectional area of the head determine where the motor is going to make peak power? Simple enough. Let's ask our community and see what people are thinking. And I have to credit Nick Rutledge, who has I've spoken about him before. He's the guy that has the 2.2. It's actually a 2.5 Dodge Turbo in a Caravan. He's drag racing it now, and I think it's making around 350 or 360 or so at the tire, and it's doing really well. And which is very, very cool that he's running it on the chassis dyno and doing modifications to it, and then taking it to the track, which is also very cool. So he's doing a lot of that stuff. But that was one of his questions today. He sent me, I get lots of messages and emails and all kinds of stuff, but he sent me a message and said, hey, what do you think about this? If I change the cross-sectional area, because he was talking about making further modifications on his combination, and we were talking about different camshafts, because I had sent him an email and said, hey, look, what I'm going to do is probably have a cam made for this thing, and he wanted to know what size I was going to do. And then he was asking about his combination, and I said, what I think you should do is you have a stock head or a stock-ish head. I think you should port the head. And then we got into a discussion on cross-sectional area. And here is my take on cross-sectional area. Obviously, like all of these different variables, it's an important thing to consider. And the more information that you have, it's always better. But here's, and we were going back and forth on this. I was trying to explain to him what I thought the difficulty in, because he wanted to know if he could increase where the motor made peak power by having a big cross-sectional area, by increasing that. And so for me, when I'm thinking about where the motor wants to make power, I'm thinking about dyno curves, because that's how I relate to all of that stuff, because I have so much of that data available to me and I've done so much testing that's kind of the way that my mind works. Okay, if I want to make peak power at a higher engine speed, what are the things that I'm going to look at? And I have to be honest, cross-sectional area has never, for me, has never entered the equation. I know that it's important, but it's not one of the things, it's not one of the top 3 things that I would look at for where wanting to make peak power at a higher engine speed. The thing that you would look at is obviously intake runner length. That's kind of my jam. So I would look at that. We would put a shorter intake manifold on there, and one that, hopefully flows more. Sometimes those things go together, sometimes they don't. But a shorter runner length will definitely want to push peak power at a higher engine speed. It's going to be not as effective down low and more effective up top. We've seen these over and over again: single plane, dual plane, short runner, long runner, a Holley high ram versus a fast manifold on an LS, all of that stuff. One of them makes more power at the top. There's a crossover at some point, and one of them makes more power down low. So if I was only interested in making more power up top or in some range, changing the runner length is really a good way to do it. The other thing, obviously, is camshaft. If you have a camshaft that has 200 degrees of duration at 50, it's not going to be a high RPM motor. If on the other hand, you have a camshaft, and depending on your displacement, if you have another camshaft that's 230 degrees at 50, it's going to want to make power at a higher engine speed. And then what that number is going to be based on the displacement of the motor and the other things like intake runner length. The other thing that I look at, obviously, is cylinder head. Now, for me, when I look at cylinder head as one of the big 3 things, I look at it in terms of flow. For me, in the past, I've always wanted a cylinder head that flows the most amount of air with the smallest port. And that may or may not be the best way to go. But because most of my stuff is street and street strip kind of based, that sort of combination has always worked out the best. Like, I've done lots of testing on, for instance, small block stuff, small block Chevy, small block Fords, and we've tested heads where we've run, like I've run the dart head, I've run a 175 and a 190 and a 210 and a 225. And while there was a little bit of trading off in different RPM ranges, there wasn't a big change in like the peak torque, whereas there was a big change in peak power. And so the bigger cross-section stuff didn't seem to hurt power nearly as much as I thought it did. And it's certainly not on this, because I ran that test, that particular test on a 302, And then I also ran it on a 363. On a 363, once we got to the 210 head, that kind of made the best power. And then the 225 head, which flowed a little bit more, was a little bit bigger, but didn't seem to make any more power than the 210 did. The other ones, the 190 did okay, and the 175 did not great because it's really too small for the power output, because that 363 had a pretty big head on it. But the bigger heads weren't really as necessary on the smaller, milder 302 because it just couldn't take advantage of it. It was the LS3, ported LS3 head test all over again, just on a small block port. So I normally would look at those things in terms of the airflow. What will the airflow of that head support? What is the number? Then after looking at those big three things, then I would start to look at other things. Like in the case of the cylinder head, I would look at coefficient of discharge. I would look at, compression ratio, static compression ratio. I might also look at dynamic compression ratio, although for me, that would still be fairly low on the totem pole. The cross-sectional area is not something that I've spent a bunch of time with. And here's the difficulty for me, and I was talking earlier about trying to separate an individual component to test. Here's the difficulty: is I don't know how you change the cross-sectional area of the port without actually changing the flow rate, because those things go hand in hand. If you take a stock head and then you port it and you make it bigger and it flows more, you've changed the cross-sectional area, but you've also changed the flow a lot. So how do we, if all you wanted to change was the effect, if all you wanted to test was the effect of the cross-sectional area change, you'd have to have a head, in my opinion, that flows exactly the same, but is bigger. And so if you did that purposely just to test that, that port's not going to be very good, almost by definition. And so, again, you're either stuck with kind of making the thing not very good by design by only, trying to look at one variable, or you're going to look at multiple variable changes. And in my opinion, in this case, the multiple variable change really would be the way to do it, because that's what's going to happen in the real world. If you do when I did all the different ported head tests, so we ran a stock LS head. So I've run stock 5.3 heads, and then we run ported versions of those from Total Engine Airflow. They'd made a lot of changes to it. They changed valve sizes. They changed chamber design, chamber volume. They changed, obviously, the flow rate of the intake and the exhaust. They changed the flow curves. They've changed the port volume of each one of them. So there's a lot of changes. But when you have a head ported, that's what's going to happen. And so if that's what you're getting, if I tell people, look, I want to make a test of a ported head, I'm not just checking cross-sectional area. I'm checking what the stock head was, and then I'm checking that ported head. And when we changed it, we got this kind of power change, whatever it was. And then what guys will do is they want to attribute that, oh, well, it's because, it shifted the RPM up higher. It's making peak power higher now, assuming that it did with maintaining the same camshaft and the same intake manifold. Did it shift power up higher? If it did, then people want to point to, oh, well, you changed the cross-sectional area. I'm like, yeah, but we also changed the airflow by, you could pick your number, 40, 50, 60 CFM. So did that have an effect on it also? And therein lies and that's why when we were having a conversation, it's difficult for me to answer, one, because I've never tested specifically that thing. So I can't tell people, I can't reach into my bag of data and go, yeah, on the 6 times where I tested specifically cross-sectional area, here's what happened. All I can do is tell them, look, when I've tested literally hundreds of heads on the flow bench and on the dyno, here's what happened when I did that. And then if we wanted to get into, and I remember going through this with Brian from Brian Tooley Racing, is making spreadsheets of every speck of data that I had when I tested like all of the LS heads. So we wanted to, and I got all this information because they did the same thing when I did the 5-liter Ford head test, is we had all the data. So we had port volumes, both the intake and exhaust. We had the minimum cross-sectional area, wherever that was in the port. We had valve size, the valve job, the chamber volume. We can't really do chamber shape other than to talk about it or speculate it. We did valve train weight. How much does the intake valve weigh? How much does the exhaust valve weigh? How much do the springs weigh and the retainers weigh? What were the spring rates? You know, we went through, and then what was the horsepower curve? What was the torque curve look like? What is the average? And all of the stuff. And so then, you know, we could take that information and correlate how those things did predominantly with that particular camshaft and that intake manifold, and that also what was the header used, what was the primary diameter, what was the primary length, what kind of merge do we have, you know, all of the stuff, because those kinds of things, that kind of information will come up later on. Okay, well, we ran a test and we didn't have an 1 7/8" header, we had an 1 3/4" header, and this different kind of thing happened. And if we wouldn't have had the data included the data about the exhaust system that we used, we wouldn't be able to, we're even speculating then, but we wouldn't even be able to speculate maybe, or give us a direction to now look in for a second test or a third test or a fourth test. We wouldn't have that information and we wouldn't know where we should go from there. So, hey, look, this one had this header and this one had this header. Let's do that test and see if we can like come to some sort of conclusion. So for me, cross-sectional area is one of those things that, like I said, as an individual thing, it's difficult to test. And then since we have multiple things, I cannot attribute one thing to, you know, one aspect of that thing. Does that thing by itself change where the thing wants to make peak power? For me, because I'm a 95%er, I look at the big things first. I know camshaft is going to change where the motor wants to make peak power. Intake runner length is definitely going to change where the motor wants to make peak power. Cylinder head flow will also change where the thing wants to make power. And I have seen in the past where port volume, although that's not nearly as good of a measurement, because we have in some cylinder heads like big blocks, we have long runners and short runners, which have different port volume. You know, the length of the actual port in the head changes port volume, but it may not change cross-sectional area. You know, there's a lot of things where that isn't absolute and doesn't tell you enough information. And that's why getting more information like this cross-sectional area, like taking coefficient of discharge, like all of this stuff is all dynamic compression. All of this stuff is good. And if you start combining all of that, you can get a little bit more accurate picture of what's going on with your combination. And also, you know, if you do a lot of testing and you have a lot of that data, it can also help you in what you might use to achieve to either get more or to figure out what you're going to get when you put together another combination. All of that is like really good stuff. So that's that's my spiel on the cross-sectional area. Let me know what you guys think. If you guys have information on Casey, take a look at Wallace Racing average cross-sectional area. They'll tell you, and this SRH induction, they go over it really well on all of the things that you have to measure, because you're going to measure average cross-sectional area. Yes, cross-sectional area and all the rest of the parts determine peak power, literally all the parts. So do you think that static compression determines where the motor makes peak power? Cylinder head port cross-section will affect the port velocity, but in most cases, if you're building a performance streetcar engine, you're better off going slightly larger on port size, slightly conservative on the cam, and a good dual plane intake and long tube headers with low restriction exhaust. D-Max, you get one of those, and then that's it. And maybe you've already had another one. Yes, there has already been another one, right? 3-angle valve jobs are good. You know, a good multi-angle valve job. Max was just watching GT45 versus a Summit, and you mentioned Turbo Tuesday. Multiple angle valve jobs usually are beneficial. A lot of the factory stuff can be a single angle. What if you were to make a venturi in the part to speed up the port velocity? Changing the port like you're talking about sometimes is difficult because of packaging. If you look at the thumbnail that I put up, and you can see because it's a section, that's actually a 2.2 liter turbo head section that was sent to David Vizard so that he knew roughly how much porting he could do on it. And so thank you, whoever sent all of those to David. He's going to be sending them back. And there's a number of them. There's the intake, the exhaust from this way and that way and all kinds of stuff. And it's good to have so that you know how much wall thickness you have to port it. But if you look at what's going on just on that side view, you'll see that there's a lot of other things that are in and around that stop you from making some sort of idealized thing. And also, do you want to speed up port velocity? What if it's too high? What if it goes supersonic? Casey, at the pinch point, usually where the push rod clearance obstructs the port, unless, like in the case of this 2.2 liter, that there's not a push rod. Just watching Sloppy Mechanics, he dynoed a stock Fairmont 4-cylinder. Yeah, 77 horsepower. What's up? What sort of CFM gains can be had from multi-angle valve jobs over stock? It depends on what stock you're talking about. Depends on what head you're talking about, what motor family it is, how bad the factory one is. It depends on a lot of things. What's going on with the rest of the seat and the transition into the bowl? Lots of things will affect what. There's no absolute thing. Is it possible to use a 4/8 connecting rod and pistons with a 5/3 crank? No. You can use the piston, but not the connecting rod. The piston is the same compression height as the 5/3. Richard, I've got an 0148. I was able to drive home like the L33 from the yard. Crack head special truck, but engine is solid. Going at 4x4 as a daily, that would be good. Is there such a thing as too much port velocity? I don't think they want them to go supersonic, right? The 4.8 liter intake manifold is the same size as the 5.3 and the same size as a 6.0, the early 6.0. And the throttle bodies are the same size. Smooth versus rough port, die grinder versus extrude. I don't know. Some people will tell you that it keeps the fuel in suspension. I haven't seen that test that shows me that. I would like to see that. Is dynamic compression more important than static? I don't think that it is. I look at the camshaft and the cam timing and the static compression differently than I do as dynamic compression. The dynamic compression thing is usually what people are trying to get an idea of to determine whether or not there will be problems with detonation. Richard, well, what's the perfect combination for Richard's streetcar that can go to the shop, be fastest off the light, and handle mountain roads? So you forgot to put in there that you want it to get 50 miles to the gallon too. It's amazing how much air flows through a port at RPM 7,000. It's hauling if you can help it flow smoothly where it wants to go. Somehow I don't see guys like SRH or Profiler giving out port velocity specs, but you can calculate those though, and especially if you have a flow bench, you can actually measure them. Richard, I presume a taller block would be needed to use the 4/8 rods on a 5/3 crank. Yeah, but I don't know. I don't think even a tall deck would accommodate that. I'd have to do the math on that to see what the difference. So we have 3.264, I think. 264, I think, is what a 4.8 is, and 3.622. And then what's the change in deck height between a standard deck and a tall deck? I don't even remember on that RHS block. I don't know why you'd want to use the 4.8 rod anyway on a 5.3 crank. I'd like to see a Ford SVO Mustang. Are you ever going to do a video on the GM Atlas 4200? Have you taken a look at all the videos that are up on the GM Atlas 4200? There should be a whole playlist dedicated to 4200s. I'm pretty sure. I think I created that. If not, look in the other guys' playlist. Lots of 4200 stuff up. Does port velocity matter and change for compression? The timing, overall volume of the intake, 5 psi in a propane bottle is different than a 50-gallon barrel, for example. Dan is going to give us some information here. Tell you my experience, port flow increases generally means more power, but not always. You can always have ports that flow more but make less power on the dyno and go slower on the track. Since you turbocharged the 8.1 Chevy, I'm curious to see you turbo the Dodge 8-liter V10. I've only ever seen one of those in the dyno. I mean, in the wild. By that I mean in the junkyard. Skog and Dickey made 2,000 horsepower on an L8T. They did that on using the L8T block, right? Did they also use the crank? They didn't use the stock internals on that. And the question about whether or not you think you can do better is not, that doesn't work on me. Does pushrod length affect engine power on a solid lifter small block Chevy? No, because on a solid lifter small block Chevy, it's going to alter valve train geometry. It needs to be the right length to give you the right valve train geometry, to give you the right contact patch from the roller lifter. I'm assuming, since it's a solid, that you also have a roller lifter. I mean, a roller, you would have a solid roller lifter, but a roller rocker. So you want the right contact patch for the roller tip on the rocker to the valve tip. Thanks for taking time out of your evening to do this. Hope the move is going smoothly. 2,000 horsepower is a lot. I've never run anything on the dyno that at 2,000 horsepower. I don't think that I would on the Westech dyno. Do you think that the 3-inch runner length on a minivan is a poor design on a mini Ram? I don't know. I wouldn't say it's a poor design. It's just going to want to make power in a different RPM range than another manifold that has a different runner length, because we know runner length does affect that. The thing that I can say about the mini Ram and the LT1 is that motor, particularly the LT1, made a lot more peak power than the L98 did. And part of that was the reason. Although I think they could have done it with something that's not as long as a tune port, but not as short as an LT1. If someone thinks that they can do better, they do it, not talk. I don't understand that, like, trying to be tough. It's like it's third grade all over again. Brian, a lower compression motor is going to draw in more air. No, I'm not moving to West Tech. Any information on the Holly Skyram dyno or any predictions? I've already seen the curves, but I was sworn to secrecy. Racer, you're trying to apply the rocker ratio earlier or later by changing the pushrod length? Richard, what V8 do you run, or is it everything you own, including your mower turbo? It's not. My Silverado is all stock. It's an 02. I do have a Omni GLH turbo, but it doesn't have a turbo on it right now because it doesn't have a motor in it. Yeah, get away the I'm better than you at the track thing. It's just insecurity on people's part. I don't understand that. I've told these stories many times. Like when I'm at Bonneville, I'm in help people mode. I'm not in I'm tougher than you and I'm going to go faster than you. When I go out, I just go as fast as I can. We set a goal to go out and break the record. And then if we do go out and break the record and get an impound and come back the next morning and set a record, that's great. I don't walk over and make fun of other people or tell them how much tougher I am than everybody else. I walk over and ask the people that that are trying to, that are in my class, if I can help at all. And we've done that many times in tech. We helped the guy that had a 240SX that a 240SX that he was trying to come out and set a record with, and he was at the time getting retech because he had blown his Lexan rear window out because he had I think he had an RB25 or a 26 motor in his car, and he had it like at 800 horsepower. We're like, dude, what are you doing? You don't need to do that. That car will go like 9,000 miles an hour with that kind of power. Yeah, but we need to go like it was 203 or whatever he needed to go. We're like, yeah, you have about twice as much power as you need to do that. He's like, what? I said, yeah. I said, that's a really aerodynamic car. I said, this is Bonneville. You got all the room to run up in the world. This is not the quarter mile. I said, at 400 horsepower, especially at the tire, that thing is going to go 200. I said, so take your 25-pound spring out of there that you have and put a 10-pound spring in it and just go make a pass. Because they had tried to go out like 3 or 4 times, and every time something had happened, it blew that window out, they'd spun, because they're trying to put like 1,000,000 horsepower down. I said, look, just go out and make a run. And they went out at 10 pounds and they went like, I don't know, 100, and I'm going to make up a number because I don't really remember what it was, but it wasn't too far off the record. It might have been like sub 190 or something like that. So now go up like 3 or 4 pounds or, whatever, go up just a little bit and go out and make a pass. Now that you know what it feels like, you have data, the air feels right, the charge temperature right, all that's right. And then on their next pass, they went back out and they were an impound because they had set a record. I said, okay, now turn it up 1 pound or whatever in the morning. It's going to be colder. It's going to love it. Go out, make another run, set your record, then go up. And when you go up, don't go up 5 or 10 pounds. Go up a little bit because it's going to go faster. Don't come out and set it on kill. And I've told the story about giving away my axles and that kind of stuff because I want to help people there. I'm not, my ego isn't attached to what's happening with the car. That's an analytical thing. That's not an ego thing for me. So you're wanting to run racer. You're saying put a longer push rod on there to have it favor the far side of the stem, that it applies it earlier, is what you're saying? $799 heads better on a 4.8. If not, what's the next best? The heads that came on your 4.8 are the ones that I would run, either an 862 or a 706. Less power with more airflow. The CSA keeps constant or variable. I don't know if I wouldn't run the Omni in the Silver State. I wouldn't run that little turbo 2.2 or 2.5 in that. That's not a good application for that. It's not a good chassis for that. It's not very aerodynamic. None of those things are good. What's the benefit of both twin turboing and supercharging a Northstar V8? I don't know what you're looking for. I would rather you have a question about asking, how do I make a given amount of power? We can help you do that. The twin turbos and a supercharger, we discussed compound boosted applications like that many times. And if you have two really big turbos and then you put the supercharger on to help the NA power make more power to help spool up the turbos, that works. Otherwise, if you just put two normal sized small twin turbos on there that you're trying to make 1,000 horsepower or less, 500 or 600, whatever the number is, you have two small turbos on it, the supercharger is really just in the way. Although it is very cool. It's much cooler to say I have a twin turbo and supercharged whatever motor it is, Northstar motor. Hopefully it will last. And that's also cool. So there are reasons to do it and reasons not to do it. Besides turbo, how can I make my 3.8 liter V6 Ecotech faster? I don't know about that engine family. I don't know if they have. I'm sure that the guys from guys in San Diego will do regrind cams for that. You could put headers on it. You could do a tune on it, that kind of thing. When are we going to see the Fox body with a twin turbo Coyote swap run at Bonneville? That's not going to happen. The Fox body is also a car that I would not be my choice for Bonneville. It was fun at the Silver State though. Michael, if you live 90 minutes from Bonneville and you've never been to Speed Week, honestly, Speed Week is really cool as a spectator because it's really, really packed. There's lots and lots of people there. So there's lots of cool, like weird stuff. I remember seeing a canoe with a motor in it that the guy ran in some class. There's golf carts. There's all kinds of crazy stuff. So, there's big rigs with stretched chassis and just, streamliners, just all kinds of amazing stuff. And it's worth just to go see that and just stand out there and watch something go by at 400 plus miles an hour. It's really kind of neat. Look at David Vizard's video on rocker ratios. Explains how to use rockers for more power. Are the wrong cam shirts available yet? Not yet. Richard, will something like variable intake size Venturi thing on intake only work with variable cam timing? Yes, the intake manifolding, having a variable intake manifold, I don't know how you're going to do a variable Venturi one. That's going to be a little bit tricky because I don't know how you're going to change that shape. But you can certainly change different lengths. And that would work well with variable cam timing as well. Because in fact, if you take a look at the Hemi that we ran, it's not mine. It belongs to the guys from Motor Trend. But that 5.7 Hemi, it's a late one, has both variable cam and variable intake manifold. Oh, the 3.8 liter Ecotech has a 3800. Okay, see, I don't know where I was going. It would take a lot of compression to lose 100 horsepower. that would be a lot. So if you're looking at 3 or 4% per point of compression, how many is that? Or was the motor making a whole lot to begin with? How excited are you for the prospect of tuning something with fully variable cam profiles? That would be very cool to put and we've talked about this many times about, because when we were talking about Formula One pneumatic valves and all this, to be able to put whatever cam profile you want in there, it would be more beneficial for not wide open throttle, because the gains that you get at wide open throttle would not be what people think. Because you have, unless you built the motor to take advantage of what all the cam timing that you had. And that's the thing that a lot of guys don't realize, is that if you had a factory motor, but you had, let's say that you had a 3800 V6 or an LS. And if you had all the things that an LS had on it, and if you had infinitely variable cam timing, you're still not going to make a whole bunch more power than you're making with that LS, because it has that intake manifold on it and has those cylinder heads on it. And so even if you could do whatever you wanted to the cam timing, let's say you made a piston that had enough piston to valve clearance that you could put a big camshaft in it, and you could put a small camshaft in it. So you make, reasonable amount of torque down low and good power on the top. It's still not going to be like, it's not going to turn your 5.3 into a 700 horsepower motor that also idles at 25 inches of vacuum and gets 50 miles per gallon and does all that. Because the camshaft has to have all the other things to go along with it to make it work. Even, look at VTEC. VTEC is a real good example of that. It's still a compromise, but, based on the other things that are there. If you're supposed to be retarding timing at least 1 pound, 1 degree per pound of boost, if you push your engine boost to 30 psi, is your ignition timing after top dead center? We don't retard it 1 degree per pound of boost. That's not a hard and fast rule. When we ran 30 pounds on the Big Bang motor, we had 18 degrees of timing in it. Freezer Racing ported 7.6s, LQ4, 236, 246. Does it have a does it have some sort of aftermarket piston in it? Because I don't know if that camshaft's going to fit stock piston to valve clearance. It seems pretty big to me, especially with the 110. Yeah, Scuba Sam, being at Bonneville when the sun comes up or when the sun goes down is also cool. Seeing the floating island is awesome. Going out there, because I've gone out there a few times. Obviously, we go out there early in the morning after you've set a record and gone into impound. You come out, all of those guys that set the records the day before get to go out first, and then they make their runs, and then they start the day for everybody else trying to set a record. And so we go out and hopefully back up our run. So we're the first guys. So it's like real, dark 30, in the morning. It's nice and cool. The motor, especially turbo motors, they love it. And it's awesome to be there and watch the sun come up, over the salt. It's just like an otherworldly kind of experience. When are you going to do a turbo air filter test? I think that would be a good one. Oh, they're fly cut pistons. Okay. Because that's a big camshaft. I think on a 6-liter like that, unless you've done a really good job on the heads would be holding that back. Did you mention what intake manifold you had on there too? Oh, a high ram. Okay. Well, that's going to do, if you ported the heads properly, that should make decent power. What was your stock ignition timing before you retarded to 18 degrees? Well, it depends on what boost level you're talking about. The NA motor wanted 29 or 30 degrees. But remember, we're running 118 race fuel, and we're also running ice water with an air-to-water cooler that has our charge temperatures about 100 degrees. We are doing a Big Bang on the K24. Who built the motor in the land speed Honda? If you're talking about the Civic, I did. Why do you use plastic gauge? I've used plastic gauge. As a matter of fact, all the Bonneville motors that I made for the Civic were all done with plastic gauge. Admiral, thank you very much. Richard, my girlfriend wants to know what you know about Audi VW stuff. Specifically, which ones? I did some stuff. I did some work with Audi, the factory team, or VW, I should say, on their GSR. A lot of people think that that's only Honda thing, but their GSR Beetle, and then before that, their Volkswagen Jetta Hybrid. And so we did a few things with the motors on those. So if you, and before that, I did chassis dyno testing with my friend's 1.8T turbo Golf too. The CSA determined peak horsepower engine speed. We're pretty split. 52% saying no and 48% saying yes. Can you run 87 octane with 11 to 1? Yes. The answer is potentially. You can run that with low timing, with softened heads, with very low water temperature, very low intake air temperature. She has an 08 TT. I like those. Those are cool. I like those cars. A 2-liter turbo. Those are good. It needs to be done up as a like the British touring cars or the German touring cars. How do you feel about alcohol? Like E85? Admiral, the same things apply to that motor that apply to everything else. You want to try to, and we did this on the motors that we were running at Bonneville. In fact, we hated the one that was in because it was an 18, I think, the GSR motor, because it had the exhaust port, like the merged exhaust port that came out, and it was really hard to get that motor not to blow itself up. We kept asking him if we could change if we could just run the last year's motor, because it had 4 conventional exhaust ports. It would be easy for us to make the motor that we wanted to make. We knew that it would do that, but you do the same thing. You do a ported head, cam timing, if all that stuff's available. Get the NA power output up. We did that with the Suzuki Kazashi. We did that with the Civic, obviously. You get the NA power output up, and then you put a turbo on it, and then we can run. That way we can run a lower boost level to make any kind of given power. We're running a turbo with an ice water, air to water intercooler. We're running, especially the second run at Bonneville is cold. Everything's happy there. We have everything wrapped so that the temperatures don't get really high. The thing never heats up. It has cool water temperature. We just make sure that there's obviously oil temperature in it. We did not run that on E85, which it probably would have made more power. We just ran it on race gas, but it's still, we were running in the Civic, we were running nowhere near what the limit of that motor was. We were only running 16 or 17 pounds when we set the record at Bonneville. Let's see. What is the coefficient discharge? What is the CD on the Civic? Do you know? And can you improve it? We did improve it in the class that we ran it on, because we ran it in fuel altered, and then we also ran it in comp coupe. So we did a number of things. We obviously lowered it. We have very narrow tires on it. We had a full belly pan on it. We had a wing on the back. We had everything was covered in the nose. We had an air dam. We took the mirrors off. We did all the stuff that you would normally do. Performance Academy over here suggested plastic gauge for crank bearing fittings. You can do that. They got pasted on the comment saying plastic gauge was inaccurate. It's not. If you know how to use it, it's been done a lot. it would be better for you to actually measure it in different spots, which I didn't do when I was doing the Bonneville motor. I only measured it in one spot. It was a go, no go kind of thing. And so it's not, and because then you're measuring the plastic gauge, which again, it's not super accurate, but we erred on the looser tolerance side when I was doing the plastic gauge. And like I said, it's worked for lots of people for a lot of times. Everybody that doesn't want to do it again, we talked about this many times, whatever their thing is, that's the best thing. It doesn't matter that everybody else has had success doing other things. Whatever the thing is that they came up with is obviously the best thing because it came from them. What engine do you think would make for a good swap? The Chevy Sprint turbo motor. Dwarf Grinder, what's the argument for no answer? Hamster? I don't understand your question. When is the 2.2 versus 3800 big bang shootout? The 2.2 is probably not getting a big bang. Thanks for the share here. Have you considered testing one of your custom long runner manifolds with injectors moved up to the runners to get carb-like charge going? We've done that many, many times. In fact, we did that on the, was it on the Jetta? I think it was on the, no, it wasn't on the Jetta. It was on the VW, on the GSR. We had stage injection on it. So we had where the injectors are down at the port in the factory position. And then also, because we made a custom intake manifold for it, there were injectors up in the ports as well. I did that on the Honda with the sliding injectors on the TWM stuff. And even those had two positions. We only used one of them kind of midway in the port and then all the way at the top. But I am going to be doing something like that later on with a much longer version. But it does change power. It does add charge cooling and it does change the power. Did you lay the front windshield back a few degrees? You can't. It's not legal. And it's not very good. I mean, it's not necessary for what we were doing. You could, if you chopped it and made the windshield shorter and laid it back and you're making it into a streamliner. We only used like 2/3 of the power that we had available. So we weren't anywhere near what that thing would do. We had a lot more power that we could have applied to it to go a lot faster. And we had more gearing and we had more RPM potential for the motor. We lost the half shaft and set the record. And then I ended up selling the car, who that guy went out and John went out and set 3 other records over 200 miles an hour in different classes in a different configuration so that they could all get their 200 mile an hour hats. That car, if I was going to go a lot faster, I think I'd want to redo the cage and stuff. It's a little old school. It's not what I would want in there now, because I think if that thing was going to go to 30 or 240, which I'm pretty sure it would, I would do it a little bit differently now. So Dan, plastic gauge has the highest profit margin of all the Federal Motor products. I would imagine that can't be very expensive. I'm sure that the package in the plastic gauge costs more than the plastic gauge does. Renee the mechanic, what's up? Let's get together and design and build a free valve head setup for an LS platform and ditch the lifters and cam and throttle body all together. I don't know if I'm qualified to do that. How is a free valve head? How is it controlled? Oh, Dwarf, you're talking about the no argument for CSA determining. Well, I think what the no argument is those guys are thinking that, like a lot of things, that has not very much of an effect, not as much as the other big things do. Have you had a chance to look at the I Do Cars? I think I did. Was that the guy that takes apart the motors? I'm going to take a look at that. Yes, I did. I did take a look at that. In fact, I'm going to be doing some. I don't know if I'll do disassemblies like that, but I'm going to do assemblies because I think guys want to see not just the dyno test part of it, the end result, which is the part that I like. They want to see assembly stuff, and so I think what I'll be doing is more hands-on assembly stuff in the future, and then go to the dyno because I think that people would like that more. Is the Dodge 360 Turbo coming along? Actually, the Dodge 360 is in the back of my truck right now, getting ready to go down to West Tech. Richard, let me know what you think. I pitched a similar idea at the Hyundai factory training event at their California headquarters, and know they have a variable cam design patent. Where is Hyundai factory training? Somewhere in Southern California. They used to have one down there. I thought that they closed it though. Dan, my point is that you get better cylinder filling just like an LS3 intake. Also, company made a monster TPI. I don't know what your first comment was, so I don't know what that was in response to. We saw you take apart a flooded 4.8. Yeah, that was not good. But I'm going to fix that, though. A Geo Metro XFI is more aerodynamic than a Civic hatch is. And a hatch is not as aerodynamic as the Civic sedan is. And none of them are as aerodynamic as an Insight is. The valve lift and duration will be controlled by solenoids linked to a controller. Free valve offers base computer logic to get us started. I think it would be better to do it on a single cylinder motor to start out with to get a feel for what it does. You see the one he takes apart a Mercury Marauder engine. It has 8 bent rods. No, I didn't watch that one. I watched a 5.3, and then I think I watched a big block one maybe. If the port was reduced to a column of air, it should at least have equivalent size to the surface area of the valve opening. I don't think you can push a valve through the port of an intake. I don't think it has that big of a cross section. I want to do a turbo 3-cylinder Mitsubishi re-sleeve and Insight. Didn't Lingenfelter flip an 88 Trans Am at 298? You mean are you talking about a Bonneville? Dan, I have dial bore gauges and micrometers and still use plastic gauge just as a sanity check to make sure I didn't screw something up. My big thing is when we're miking like bearings and stuff, I take the sliding dial caliper, like a digital one, and then I'll put it in there and just check to make sure that I'm adjusting the mic properly. I don't know why, it just makes me feel better. Koenigsegg is making 600 horsepower from their 3-cylinder. I've seen it. I've read about it. It's very, very cool. That Larry, that must have been a long time ago then, right? Because John's been gone for a long time. I am going back to West Tech, yeah. 2 more minutes. That's why the Dodge is loaded up in the truck. And I have to drop off the 292 parts that a gentleman let me borrow, the dual carb stuff, and then also the turbo, the dedicated turbo manifold. Oh, in the 90s, yeah. That makes sense. So we will close out our poll at 192 votes. Thank you, guys. 45% saying yes and 55% saying no, that the cross-sectional area, does it determine peak horsepower engine speed? How well does boost work on a dual plane intake manifold? The same as it works NA. It works very well. Yeah, Casey, that's always the problem, is when you use plastic gauge, getting the plastic gauge back off of the bearings, because then it seems like you scrape it off, and the plastic gauge wants to adhere to it unless you take like surface off of the bearing. Can't proper cross-sectional area be calculated for? Yeah, they use RPM and displacement, but you want to add, you want to also use that to then calculate velocity, because then you get more data, which is always good. Your other friends don't talk to you like this, Eric? Getaway, I'm buying a 2008 Yaris. I had one of those. I think mine was might have been a 7. Going to hopefully swap out that 1 liter for something bigger. The Trans Ams back in the day were really aero. In fact, that was for a long time, that was the most aerodynamic factory, or it had the lowest CD. It didn't have I think that I don't know what the frontal area was. It probably would have been more than a lot like the Insight and stuff, but I think it was a 0.28 or a 0.29. It was pretty low. Casey, your next poll should be, is boost cool? Or does boost make more power? I'm still going to get somebody that says no. I think that's when they were trying to go 300 in a stock body car. Denny Kaler wrote his Porsche 911 Turbo there at 200. That's not good. Yeah, the Aero one didn't have it had like pop-up lights, right? So they were closed. Thoughts on Edelbrock's new 4150 style carburetor? I haven't tried it, and I haven't seen one at West Tech either, so I don't know. I don't really have anything to say about it. Yeah, the second generation RX-7s were good. Anything pointy like that. The really critical thing that a lot of people don't realize is what's going on the backside. Because like if you look at I remember the guys from I think Car and Driver did that. They went out with an S2000, which had a really good motor. It was pretty aerodynamic, but but the backside of it was terrible. And when you don't have air that goes down smoothly off of the back of the car, it creates lift. And when it creates lift on a rear-wheel drive car, it wants to get all wonky. That's not good. Dan, I'm sure you've done this. If you put the valve in backwards on the flow bench, the port won't flow anymore. Do you mean just stick it in from the top? Is that what you're talking about? I'm sure that they have school buses out there, Casey. My Del Sol is a good example of that too. That the way that when it goes over the roof, and then you have that flat back window and then the deck lid. It's not a great choice, because it wants to, when you have air going down there, you have a low pressure there and it wants to lift. Jeep, Richard, I'm so confused on how to get the right injector size. Well, tell me how much power you want to make, and I'll tell you what injector size to use. On an NA motor, just multiply the flow of the injector by 16, and that will tell you how much power it will support. So a 50-pound injector times 16 will support 800 horsepower on an NA motor at 0.5 brake specific on gas, not on E85. Flat under tray on a car, yeah, it gets rid of form drag. The belly pan's always a good idea. What happens, James, what happens if you push the plastic gauge through to the other side of the bearing? The advantages of free valve technology is the loss of centrifugal mass on the rotating assembly. Are you talking about the camshaft then? Obviously higher RPM. Oh, stick the valve in just to plug the guide, yeah. Because if you float it with the guide open, it probably would flow more, right? It's a basic test to see how much the port can flow. It's often the same as high valve lift. What I do is when I put it on there and clamp it down, I just, before I even adjust the dial indicator or anything, I just push the valve all the way open. I just set it on 4 or 5 or 6 or whatever I think the thing is going to flow at. And then I turn the airflow bench on, and then I just push the valve all the way down. And I might even vary it just a little bit just to get an idea if am I past the point of where it's flowing the most amount? Is it, is there another sweet spot that's going to flow a little bit more? But at least gives me an idea. I'm like, okay, well, this head is going to flow 300. Oh no, this head's only going to flow 200. It gives me, we're looking for broad strokes here. Yep, multiply injector flow by 16. That's for an NA one. And then if you want to multiply that by, I don't know, what did I say is 0.75 would give you an idea for E85. So if we're at 13.2 minus 11.5 equals divided by 11.5, 14%. So if you multiply by 0.85, after you get that number, if you multiply by 0.85, give you an idea what it will do under boost. And then multiply that number by 0.75. And this is when you start doing this, you're like, oh yeah, I need a lot bigger injector for E85 under boost. That will tell you what you can do for E85. There's a fella on YouTube that made his own free valve on a Miata. I was watching that. I didn't see the finished thing though. Yeah, coefficient of discharge is only one thing. You got to do frontal area. I don't remember if we ever did a frontal area. Just shine the light on it and then put a grid on, like you could do it on your on any kind of wall. You could do it on your garage and stuff. Make a wall and put 1 foot squares or whatever, 1 inch squares, how much ever you want to delineate it. And then you just shine a light on it that's directly in back of it and go, okay, look, we have this much. And you can get a pretty good idea. What are NA48 mods that could pep up the engine? Cam is a given. Yeah, I would use a small cam, and we've talked about that on the 4.8. A small cam, headers are good, tune, obviously. Eric, happy to help, man. Yeah, Dan, if you could if you could make them a lot narrower, that works really good for speed on the super speedways. Would you use the same gap on 2 pistons, the same size but different material? I would, yeah. I would, because you're gonna, yeah, I would, because I don't think it's gonna hurt you. And I'm giving, when I give the reference for ring gap, I'm overstating it. So it's more than enough for whatever kind of material you have. And I think the kind of materials that you would have, the change in material that you have for 2 pistons, the ones that would be common and that you would use, you're not going to see much of a change in necessary ring gap for those. Are flat spoilers you see extending out the trunk on a Fox body for sure? Are you talking about the drag race ones? Yes, they work very well. I had one on my Mustang when we ran it for top speed when we were running at the Silver State. And the fences on the outside are really important too, so the air doesn't spill over, so it keeps it in the center. And you have a little gurney lip maybe. We have a big spoiler that stuck off the back of the Civic too. The longer that you can make it, the more aerodynamic it's going to be. The ideal situation for Bonneville actually is to have, if you can have the air going over, like the windshield's a terrible thing. That's why you have high pressure built up for your vents, and that's why you can have air blowing into your car. So that's a high pressure area. That's not good. Obviously, if that wasn't there and it was just smooth, that would be better. But once the air goes, if you can get it to stay attached and then have it go smoothly exiting the back without becoming unstable, like I said, having a low pressure area there. If you can have the back like taper down, the teardrop shape is the ideal thing. And that's why you see some streamliners that were like that. If you have them taper back and have the air stay attached the whole time and transition smoothly behind the car, because that's what happens is if you create a low pressure area behind the car, it pulls on the car. That's aerodynamic drag. So you want all the air to go like merge smoothly, stuff from coming under the car. Hopefully you don't have a lot of that. And then stuff coming from over the top of the car. Wicker bills, yes, gurney lips or wicker bills, all of that. 0.07 gap for high boost, yeah, per inch of bore, that's good. Honda Insight's really good. Tom, all right, man, we'll see you. You can give me a call tomorrow. I'll be driving. Wicker bills, gurney lips, gurney bubbles. Dan influenced a lot of things. What was the CD of the Goldenrod? I don't know. I actually got to sit in that car. They had it at West Tech for a long time. It was pretty cool. It was in when they had it there. It was pre-restoration, so it was kind of in dire need of needing to be done. But it was very, very cool, though. Wouldn't a higher torque cam help with fuel economy in such a way as you wouldn't need as much throttle input to move the vehicle? Well, here's the counter argument to that, and that's that you would actually get better fuel mileage with more throttle angle because you reduce pumping losses. You should build a streamliner for your turbo sprint engine. I don't even, all I want is a turbo sprint for my turbo sprint engine. Somebody actually mentioned one today, but I can't get another vehicle that doesn't run. So I unfortunately had to turn him down. But I would want to take the sprint back out there and set records in the sprint. The cool thing about the sprint is they're not going to be very fast. So I don't have to put like these elaborate 200-mile-an-hour cages and all that stuff in there. So, and that's what was going on with the one that I had that eventually got stolen and then crushed. It's terrible. But I'd like to take that thing to Bonneville because I know it would set more records. What happened to all the books and the magazines? They're actually in boxes. They're going to get moved. If you push past the mental block, I can, but I won't be able to move them. I don't have a place for them. Yeah, Dan, there's some really good stories about the Summers brothers and the fight that they had with Chrysler and the engineers and the mailbox air scoop openings. And it's really, really good stuff. The Bloodhound LSR project. I don't even know what that is. I'm sure it's some kind of land speed record, but I don't know what the Bloodhound is. Blind guy, K24 with a turbo on it would be good in the Nova. Oh, it's supposed to break 1,000 miles an hour. That's kind of the next big thing, right? That will be cool. See if they do that. I hope that somebody does. Michael, that might be a good question for Dan. I don't know if you could do a set of SB2 heads be drilled to work with reverse cooling on the Gen 2 LT1s. Do the NASCAR guys run reverse cooling anyway? Bloodhound is the English company. They were the ones behind the Thrust SSC land speed car. Spirit of America, that's old school. That's Craig Breedlove or Gary Gabelich and the Blue Flame, the Green Monster, R Fonz. There's lots of good stuff. Richard, have you ever met Marlo Trait? I'm not familiar with the name. He's trying to reset the piston-driven record at Bonneville. So is he who has that now? Does the Speed Demon one have that? Yamaha RX-50. Brian, is a 4.8 or a K swap better for NA? A 4.8 will make a lot more power than a K series will, an NA one. I think that, and I'm surprised that they don't. They need Barstool land speed records. Does Danny Thompson has it now? Well, let's ask and find out. Wheel-driven land speed record. The new wheel Turbinator 2 uses a Chinook helicopter. This is in 2018. 777 kilometers per hour. The Vesco Turbinator is what it's saying. Oh, wait, that's 2001. Why is it even showing me that? Yeah, it's saying the Turbinator 2 set a land speed record. That thing's really cool looking. 483 miles an hour. How fast is the Speed Demon gone? Ooh, it said that the Turbinator hit 503 miles an hour. That's 500 is a lot. What's that in real speed? Yeah, 482. And it said that vehicle went 503. It was clocked at 503. Brian, does the 4.8 rev any higher or have quicker response than the big boy LSs? I don't know what you mean by that. Yeah, I think that they may have separate records for the that one was a turbine, and so they may have different. They may have piston engine ones. that was wheel driven, because they were driving the wheels with the power from the turbine. But the thing is, it's not power. There's no shortage of power from any of these combinations to go. They could all go for 500 miles an hour. Certainly Speed Demon could. They have enough power to do that, but whether or not they can get like the ideal run with, traction and weather and salt conditions and all that to do what they need to do, that's always the problem. If they had, if we had a 20-mile stretch of asphalt that was perfectly flat somewhere, those guys would be going really fast. What do I think about the cross-sectional area? We talked about that at the beginning of all this. When you change the cross-sectional area, normally you also change the airflow. It's not one of the cross-sectional area for me is not one of the big three things that change where the thing wants to make peak power. Yeah, 500 is a lot. It's more than I would go probably. I haven't even been half of that. Yeah, they do, Dan. They do have some of them do have aluminum wheels. I have a 418 with ported 317 heads with an LSX RT. That's a decent combination, but even the best ported 317 heads, I don't think are going to be what a ported 317 would be better than a stock LS3 head, but a ported style LS3 head would make more power. Exactly, Dan. The thing that shocks me with regard to that are the guys that do it on motorcycles. Like being in a car with a cage and stuff, because like at 500, you're just like, oh, I hope nothing goes wrong. But there are guys out there in Streamliner motorcycles where they're in the front of the nose cone. They're laying down head first in the nose cone. That's crazy. And also just the guys that ride on bikes. Because like if you have a 400 or 500 horsepower turbo 1-liter sport bike or a 1300 or whatever size it is, and you're going to go 240 or 250 miles an hour on a bike, that's just nuts. Yeah, aerodynamic drag is the thing that they have to overcome. But at Bonneville, for these guys, they wish that was the only thing. Their thing is traction. They have enough power and they have the aerodynamics. So the combination of power that they have and the aerodynamics that they have, they know that it will go that fast. But they can't put all that power down on the salt to be able to make it go that fast. To have them see them spinning the tire at the 3 or 4 or 5 mile mark when they're trying to put all their power down. Yes, the CT90 is running and driving around great. Bike speed is different than car speed. Yeah, yes, it probably seems like it's a lot faster. I've been 140 or 150 on a bike on the street, but that was a long time ago. Yeah, a play or a boat is the same thing. I think I've been 95 in a boat, and that's more than enough for me. GT2252, good turbo for a 1-liter sport bike. Yeah, how much power are you trying to make? I need to look up the map on that. Some of those 1-liter bikes make a lot of power. I don't know what a 2252 will go to. Detune, top fuel, crazy gearing, and a 2-mile runway. A top fuel is not going to make it that far. Yeah, Dan, it will. They'll definitely slow down fast. The opposite, a bike feels way slower. I've been fast on a bike and it doesn't feel slow. because you're out in the open, you're out in the elements while you're tucked down behind the fairing. And when you stick your head up, it wants to yank you off the bike. So make sure that you don't do that until after you slow down. 73 on a single person jet ski is crazy. Yeah, I've been on a some family friends had one of the supercharged versions that I think would go. I thought he said it would go 70, and it's just like a silly amount of speed. Oh, so 250 horsepower max, that would be in that range of that, because that's the kind of turbo that I was looking at for the sprint motor, and that's kind of about where we wanted it to be. Michael, who spends $60,000 to $100,000 builds to make 1,200 horsepower? You you could do that for less than $6,000. Yeah, how much cooling does a top fuel car have, or a top alcohol car? I mean, an alcohol would be nice because it's cooling already, but what's the cooling system in those? Do they even run cooling in them? Seventy on a three-person feels okay, but uh, a single ski would be really bad. Aren't some of the land speed guys running Pro Line or 481X engines? I don't know. The one that I was looking at, what Duttweiler did, and I don't know what block and stuff he's using. The other thing that's amazing in those streamliners is that the motors even last with how well they're packaged in there, and they got no cooling and stuff. Do you have a shop in Fort Lauderdale, Florida? Nope. Kurt, I don't have an answer to your question. I always recommend intercooling and low compression if you're going to run on pump gas. Blind guy. Yeah, I think I've been 40 on a bike on a downhill when I was riding with my wife. She did triathlon, so I was out training with her, and I like to go fast on a bike. Oh, no cooling in top field? I didn't think so. So I've seen a lot of roll racing between high horsepower street cars and bikes, and in fact, when I went to a Motor Trend deal. I think it was Motor Trend, where we did standing mile stuff, and they did a race. Hennessy had a Viper there, his twin turbo Viper, and then they also had an Indy car there and a Trans Am car. I thought they had some other kind of road race car, maybe a Daytona prototype or something. And they raced all of the cars, and then they had some sort of hot 1 liter kind of super bike there, not an Aprilia, but something like that. One of the Italian ones. It wasn't a Ducati. And they raced him, and the bike was super fast, like off the line and stuff. But it eventually, like at about the half-mile mark, it eventually got worked over by the cars, because the bike has really good power to weight, but then it's struggling for power versus aero. And so that's where a car that can't put all its power down, that has 1,000 horsepower or something, 1,000 horsepower versus its aero, starts to like motor away. Let's see. Bonneville. That's very cool on the Bonneville bicycle deal, that 100 and almost 184 miles an hour because they were behind a chase vehicle basically that was getting rid of all the aero drag, and so they were, obviously they had giant legs and lots of gearing and all that. That's really, really impressive. Richard, do you know if you can change jets? Can you mix E85 and two-stroke oil? It's something I've never tried. Why do you want to run two-stroke oil? Yeah, it was the vehicle was kind of creating a low pressure area for the bike to go through. Oh, you're giving it a shot with your weed eater. Try it and see what happens. I mean, not like you're going to hurt it. Richard, was the bicycle behind the Porsche 935 with that goofy thing on the back? It had some sort of like tent enclosure. That's all. I just looked at it very quickly. It just had some sort of enclosure there showing the photo, looking from the vehicle back toward the person on the bike and through this tunnel of stuff that was there. And I was looking at the other records that were basically on flat level ground that a person was actually riding, and they went 81 miles an hour, which is really fast with no aero aids. I think that they may have been. I need to look and see. That one might be a recumbent bicycle with a nose cone on it. Richard, can you make an Atlas 4200, 2500 horsepower? No, I can't do that. Yeah, the gearing on those was amazing. I remember seeing them try to break a record on they were doing it on rollers too, so that they could, it was a stationary bike set up on a roller machine basically to get the highest speed. And the crank sprocket on or whatever, the pedal sprocket, it's like about this big. The Bear is still sitting, taken apart right now. Okay, guys, I got to get going. Thank you all for showing up. I'll have more videos coming up, so I'll see you guys all tomorrow. Boom! And end.